Hi everyone. So today I'll be presenting AutoVisual, a tool to automate screen reader accessibility in charts. So following the World Health Organization, we know that globally, at least 2.2 billion people face some type of visual impairment, an issue accentuated by the high percentage of inaccessibility on the web. So despite these challenges, people still rely on data visualizations on the web for example, to check either weather updates or even pandemic numbers. So even if you are not familiar with this particular definition, we could say that the data visualization is a display of data designed to enable analysis, exploration, and discovery. This flexibility not only enhances the creativity of the chart creators, but also paves the way for innovations in the topic of accessibility. A great part of accessibility research in the past on the realm of data visualization has focused a lot on color issues, but there are other barriers beyond this one that do not solve problems of, for example, users of assistive technologies like those of screen readers. For those not familiar with this technology, screen readers are a type of software for blind or visually impaired users to read the text that is displayed on a computer screen, which with either a speech synthesizer or a braille display. So common examples of these include the VoiceOver by Apple, NVDA, and JAWS. In the context of data visualization, when exploring data visualizations, users of these softwares tend to retrieve information 61% less accurately than non-screen reader users, and also take 211% longer during interactions with data visualizations when compared to non-screen reader users. So before lining up how we could help these users overcome these accessibility barriers in charts, we began doing our research. So starting off with the Web Content Accessibility Guidelines, these are the standard to make digital content accessible online, but they fall short in more narrow contexts like those of data visualizations. And that's why researchers extended WCAG with more guidelines, creating chartability. One of Chartability multiple critical guidelines says that the visualizations should have a title, a summary, or a caption, ultimately creating descriptions that, following other authors in the literature, can be categorized into multiple levels, which emphasizes the need to manually write short descriptions that are more complex. However, accessible data visualizations involve more than just short descriptions. As for creating accessible charts, we developers could either use visualization libraries, which provide the means to create various types of charts, which commonly don't have accessibility concerns by default, but we can add them if we wanted to. Then we have visualization libraries with accessibility features by default, but they normally come at a cost of other features, customization, and having fewer chart types than normal. And lastly, we have tools that provide accessibility features to screen reader users after the charts were already created. And although these are very powerful tools in their domains, even these do not cover all the features recommended by the mentioned sets of guidelines, forcing their manual implementation, which still relies on the accessibility knowledge and expertise that developers might not have. So, since while doing our literature review, we found solutions that only partially cover both screen reader users and developers' difficulties, this led us to the creation of our own tool. So, prior to the development phase, we explored both WCAG and chartability heuristics, looking for design failures that we should avoid at all costs while creating this new tool, but also conducted exploratory interviews with 5 screen reader users and 5 developers at FISA, trying to understand their pains towards, respectively, exploring and creating accessible data visualizations. So from these interviews, it was gathered that in case of screen reader users, charts get skipped a lot by their screen readers, that since they are generally inaccessible, these users rely a lot on table alternatives, but even when they encounter accessible visualizations with accessible considerations, these still lack details and information, have features that do not work with specific screen readers and browsers, together with having complex interactions and useful information for the task at hand, together with the clashing of shortcuts between the visualization ones and others. So as for the developers, they justify the inaccessibility of their charts they produced as having lack of time during projects, lack of accessibility knowledge, lack of priority over other features during projects, and also lack of tools that satisfy all the needs in this task of adding accessibility to charts. So having all of this information gathered, it was defined that this new tool should comply with the mentioned accessibility guidelines, be a package easily imported by the developer, allow one to override the automatically generated features, which we do provide, make visualization features navigable and informative to screen reader users, and warn these users when changes occur in the visualization. But also, together with these, provide multiple ways of exploring a given chart, summarize the main content of the visualization through a description, minimize the impact of possible errors and limitations using large language models, which we pretended to use, support multiple screen readers, and also avoid overwhelming users with information. So having these requirements, we began developing the tool, which ultimately led us to the creation of the first prototype of what became AutoVizuA11y. So this AutoVizuA11y, it's the tool that we propose that automatically adds accessibility features to additive visualization, making it explorable by screen reader users without relying on the knowledge of developers. So getting into the tool as a solution for developers, AutoVizuA11y is basically a React component, which is easily installed via NPM and imported in the project. Then the AutoVizuA11y component should wrap the chart built with any visualization library that explicitly creates DOM elements for each data element, like, for instance, SVG-based charts. And finally, a set of properties should be filled with information that is most of the times already available to the developer, like, let's say, the data, the type of the chart, and its title. So these three steps are enough to provide a complete set of accessibility features that make visualizations fully explorable by screen reader users. In the context of these screen reader users, AutoVizuA11y on a higher level, it adds keyboard accessibility charts on the web. It adds multiple levels of exploration between charts in case more than one is present in a given interface, between underlying data elements, which are identified by the developer, and between different series of data, again, in case more than one is present in a chart. Also, given the navigation between visualizations, it offers a seamless experience between different AutoVizuA11y charts, which becomes very useful in interfaces like those of dashboards. Also, when first encountering an AutoVizuA11y chart, the screen reader points the user to what we call the shortcut guide, where a tutorial and the available shortcuts can be heard. More on that later. And most importantly, it provides features that we categorized into three key pillars. So those are the descriptions, data insights, but also navigation. Starting off with description. So when focusing one of AutoVizuA11y charts with a keyboard, the users can hear one of two descriptions for each chart, a shorter description or a longer one. These descriptions are automatically generated using a large language model from the OpenAI API, but because we knew some developers would prefer to manually provide their own descriptions, we also made that an alternative option. In this summary example, the screen reader would announce the title of the chart, its type, whether or not the description was automatically generated, and finally, one of two descriptions of the data, those being the longer and the shorter description. So the longer one is the first one being generated by the large language model without any size restrictions. Afterwards, the result is registered and sent back to the model in a second prompt where we asked for a 60-word summary of it. This second output is then registered as the shorter description, which is the one being read by default by the screen reader. But users can alternate between one another as needed. Then we have data insights. So one requirement that we gathered in the interviews with screen reader users was the ability to easily know some statistical insights from the chart. They can be requested while keyboard focused, either the chart or any of the underlying elements. That said, users can ask for the minimum, average, and maximum values of a chart, and additionally, while focused on a specific data element, they can compare it against the same three insights, or alternatively, know how it compares against other elements in the same chart. Lastly, on the realm of navigation, as hinted, users can navigate horizontally between different charts built with AutoVisually and between different elements using either the left and right arrow keys or Tab and Shift Tab. They can also navigate vertically, so entering and exiting a chart per se, using the up and down arrow keys. Additionally, in case that more than one series of data is present in a chart, they can also quickly jump between one another. In addition to this navigation, we added some quality of life shortcuts to easily jump to the beginning and end of a chart, but also to define how many points to jump in a given chart. Both features helpful in complex visualizations with too many data points. Finally, as you probably notice, we heavily rely on shortcuts for each of AutoVisually's pillars. So since we did not expect all screen reader users to know all of the shortcuts, we provided this guide that not only explains the tool when entering it, but also explains each available shortcut together with their key combinations. So to access the performance of the tool AutoVisually, we conducted an usability test with 15 screen reader users, different from the ones previously interviewed, where they had to complete 8 tasks in an interface whose context revolved around a fictional bank account. Both the dashboard, the layout, as well as the chart types you can see were based on a real-world scenario at Fitsai. So as for the data collected, we registered each time on task, the task success rate, the use method of completion for the chart, so is either description, navigation, or shortcuts. Also, participants got to complete the system usability scale questionnaire about the interface, but also give verbal feedback throughout the entire sessions. The tasks themselves spanned across different charts in the interface, where participants had to, for instance, count the total number of values, calculate some statistical insights, compare a value to others, and also even try to uncover what is the position of a given data value in relation to all others in a chart. To summarize the quantitative results gathered, the users took, on average, 66 seconds to complete each individual task and achieved a global success rate of 89%. After the tasks were completed, they also got to complete this system usability scale questionnaire, giving AutoVisually a score of 83.5. So regarding qualitative results, users positively commented on the experience by saying that, for instance, the tool at a very short learning curve, making it possible to discuss results with others, and that it should be mandatory everywhere as a tool for creating charts. Others specifically praised certain AutoVisually features, like by saying that the insights provided by the descriptions were very insightful. Some said that the navigation was simple enough for them, and others that the shortcuts sped up the entire process a lot. So in addition to this usability test, we also got to gather insights from 2 external developers that got to use the tool in some of their projects. Their feedback, although from a small sample, highlighted that AutoVisually effectively addresses an existing gap in their short creation process. In fact, both developers said that they would likely recommend AutoVisually to others. Other actionable insights retrieved were the fact that the data format was not clear enough for them, that the backend could be more modular, that there was a lack of examples provided in the interface that we created with AutoVisually examples, and also that there was no typing syntax support. All of these things are either being worked on at this very moment, or we plan to in the future through the ongoing support that we have planned for AutoVisually. In fact, in the near future, we want to, for instance, convert the entire code base to TypeScript, make better usage of React's APIs, find a way to automatically enable focus mode for both JAWS and NVDA users so that they are more able to navigate with the keyboard arrow keys. Also, update the examples interface with more examples and code peer reviews, validate that the tool AutoVisually works with tables, even though we believe so, we haven't tested it yet. Also, and enable shortcuts and the guide itself to be customized by the developer, the shortcut guide being the only thing that is visual by AutoVisually, and more. And basically that's it. A big thanks to everyone involved in this project, from my colleagues, reviewers, to also the users that got to test the tool. In case you are interested in the project, you may check its publicly available repository on GitHub, or even contact us directly. Thank you.